Alright, today's topic is linearity and continuity of graphs, part 2. Okay, so there's the first part we talked about function versus different types of functions you can have, continuous, discrete, or neither. This one we're going to talk about, and then we also talked about what separates or what differentiates a linear and nonlinear graph. And here we're going to go more into another step into linearity here. So when you're looking at a table, okay, linear functions must show a constant increase or decrease. Okay, so basically, I'll write that out for you. So when in a table, okay, a function must show a constant increase or decrease. Okay, so what do I mean by that? Well, when you're looking at a table of numbers with x and y, it has to go up or down at the same rate. Okay, and I'll explain that right now. Okay, so I'm going to show you this definition down here. So, what does this mean? Let's say we have a table. Okay, table of data. All right, now let's do this, and we'll have this. We'll have x. We'll have y. Okay. So we have, let's see, 1, 2, 3, 4. Okay. So let's say we have a table of data. We have these numbers in here. Let's go. Let's look at this different color. -2, 1, 2, 5, 7. And here we have 8, -1, -4, -13. -19. Okay. So here's our points. Here's x and y, right? Each data on this table is a point on a line. Okay, on a function. Okay. So -2, 8, 1, -1, 2, -4, 5, -13, 7, -19. So well, we need to figure out if this is linear or nonlinear. If it changes constant or consistent, then it would be a linear graph. So how does that make sense? How do we figure this out? Well, the change in y over change in x, okay, must be consistent. Okay, what do I mean by that? Change, the difference, the subtraction. Okay, so you're going to go through and we're going to subtract each point from each other to figure out what the difference is between each one. Okay, so let's look at these two here. All right, -2 and 1. How much is between -2 and 1? What's the difference between those two? Well, it would be 3, right? Because when you do 1 minus -2, you get 3, right? It turns into a plus, right? You get 3, okay? Now let's do 1 and 2. What's the difference between 1 and 2? Well, it's 1, right? Because 2 minus 1 equals 1. How about 2 and 5? 5 minus 2 equals 3, so 3. And here, 7 minus 5 equals 2, so 2. So here are your numbers, 3, 1, 3, 2. That's the difference between each of these one here. Okay, I just subtracted 1 from the one like that, all right? Now let's do the y's. That was the x's, now it's the y's. So the y's, we have 8, -1, so -1 minus 8 gives us a -9. So so really your change in this would be 9, right? Doesn't matter if it's positive or negative. The change is 9, okay? -4 minus -1 equals 3. Remember, plus plus. -3. So the difference is 3. -13 minus -4 equals -9, which in case would just be 9. And the last one, -19 minus -13 would be -6, which would just be 6 here. Okay. So this is the difference. I just subtracted each of these numbers from each other. Okay, to find the difference of it. Now that we have done that, I had to put it in here to see if it's consistent, the change in y over the change in x. So in this case, my y, in this case, is 9. In this first one, 9, all right, over 3. So our y, right, our y over x, okay. So here, I'll write this out. I'll write this out like this to kind of make it a little easier to see. So y over x equals 9 over 3. If you divide that, 9 divided by 3, we get 3. Okay, here, 3 is our y, right? So 3 over 1. You divide that, you get 3. 3 divided by 1, right? 9 over 3, divide that, you get 3. And here, 6 is our y over 2. You divide that, you get 3. So if you look, our change, right, each number here, when you divide it, the change is, the division of it is 3, okay? So this is why, yes, it's linear, okay? Because of this part right here. Okay, it's consistent, it makes it, it's all the same numbers here, okay, when you do it that way, all right? Now let me show you a way in when it's not linear, okay? And you'll see how this is different. And so I'm going to erase all this. Don't put drawing the graph, so bear with me. Alright, so now if I have numbers that are like this, let's do -2, oops, sorry, on marker, -2, 4, -1, 1, 0, -5, 1, -9, 2, -10. Okay. So once again, let's go through and let's find the change, the difference of each x and y, okay? So -1 minus 2 and -2, the difference would be 1, -1, 0 would be 1, 0 and 1 would be 1, 1 and 2 would be 1, right? So basically you can see how each time this goes up, it goes up by 1 each time. -2, -1, 0, 1, 2. It goes up by 1 each time, right? Now on this side, 4 and 1, your difference is 3, right? It goes down by 3. Okay? 1 and -5, it goes down by 6. -5 and -9 goes down by 4. And -9, -10 goes down by 1, right? So this time, these ones go down by 3, down by 6, down by 4, down by 1. Now, if we were to put this, our change in y over x, we have 3 over 1, which equals 3. 6 over 1, which equals 6. 4 over 1, which equals 4, and 1 over 1, which equals 1. So here, you can see that after I did, my y over x, my change, my y over x, y 3 over 1x, right? All these numbers are different, which means no, not linear. Okay. So that's what I mean by that. That's what I mean by constant. The constant has to be the same. It has to be consistent each time. Okay. So this number, so it has to go up the same here, change-wise, for it to be linear.